So in this video, we're actually going to be looking at some tissues from connective tissues. And again, just to kind of give a basic idea, so we have, there's basically two types of connective tissue. We said in the previous video, you got connective tissue proper and then specialized connective tissue. Now, for us in lab, there's a couple of things on this list that we're not going to be seeing in lab, and I'll just kind of briefly talk about them, but I really am going to concentrate um, mainly on the ones that we really focus on in lab, and even in lecture in our tests, I'm going to, the lab, I want the lab and the lecture to kind of overlap some. So anyway, connective tissue proper is also subdivided. We have loose and dense connective tissue. And this is simply talking about how the fibers are all arranged. Obviously, loose connective tissue, the collagen fibers are more random and kind of mixed around. There's fewer, as it says here, fibers. And in dense connective tissue, the fibers are very abundant. And it is kind of what the majority of that tissue is going to be that fiber. And so we'll kind of see that as we look at it in the specialized connective tissue, cartilage, bone, and blood. These are very unique, and again, we'll see these and see the pictures of them as we go through. So loose connective tissue is what we start with. All right, so the first one we're going to look at is areolar. I'm hoping that when you hear this, you automatically think hair fibers, because this is the one on our lab slides. It has these dark lines in it that we will see are collagen and elastic fibers that make up the most unique aspect of the tissue slide. It looks like someone had just gotten their hair cut and were making the tissue slide, and their cut hair fell on it, and it just kind of got caught under the cover slip. So anyway, it is very thin, delicate membranes. It is going to have a lot of fibroblasts because, again, the fibers are going to be something you can kind of tell and see with this, the defining feature. It is in that bottom layer of the integumentary system. Again, by this point, we've already looked at that in lab. The integumentary system, the epidermis, dermis, and the hypodermis can also be called the subcutaneous, because again, the dermis and the epidermis make up what we call the cutaneous membrane. It's going to be between most of the epithelial tissue and the connective. That's the go-between, kind of between that. And so when you get into dissection, you'll see this little very fragile tissue, and as we separate certain things, you'll see it almost looks like, lack of a better way to describe it, like cotton candy, because it'll just kind of disappear, and that is areolar tissue. But this is our tissue slide from lab. Again, the defining feature are these little hair strands all throughout it, and no other tissue slide that we have looks like that. So the next one we look at is adipose tissue. Again, adipose tissue is just the scientific way of saying fat. So adipose tissue is commonly called fat. The adipocyte, little part in there that is where the fat is stored. It's going to be the majority. This adipose is going to be the majority of the inside of the cell. So all the nuclei are kind of pushed to the side. It cushions and insulates. It is also in the subcutaneous layer, and it is found all over the body, unfortunately, in a lot of ways. So this is our slide of it. We said it looks very similar to simple squamous epithelium, except that the main thing is, in simple squamous epithelium, there's always going to be tissue damage. And unless it was a beginner that was making a tissue slide, adipose tissue very rarely, if ever, is going to have any tissue damage, because actually adipose is one of the easiest tissues to make a tissue slide from. So you can kind of see that the little the nuclei are pushed off to the side, as it says. That's one of the defining features. Again, if you're going through the book-wise way of naming these cells, that's kind of what you look at. Oh, all of this. These are just big hollow. It looks like it's not hollow because it's filled with adipose or triglycerides. Anyway. The big thing is, the book-wise looking at it, is that there's only a few nuclei, big nuclei around each one of those spots, unlike the simple squamous, where in the round spot, which is just empty, you got dozens of little nuclei around it. But the real easy way to see is the tissue damage aspect of it. So these are areolar and adipose tissue. Again, I'm not going to get too far into this. We covered it in lab, but those are them. This is the book picture that they show. Even in this one, you can see all of these crazy fibers all over the place. And again, in this, this is a little lighter, but you can see the nuclei are just kind of pushed off to the side on here. And again, no tissue damage. Now, in this, again, two more that we have from lab: reticular connective tissue. Reticular connective tissue, we said, looks like brown tree bark. You'll see that in a minute. It is thin. It is thin fibers of reticular protein, and so collagen protein, I should say. So it is going to be in the internal walls of organs, as it says, in the liver and the spleen. It is a delicate framework. And this is our picture of it. Like I said, it looks like brown tree bark. Then we come to dense, regular connective tissue. Densely packed, regularly lined fibers. All right. This is bunches and bunches of collagen fibers. The majority of this tissue is are these fibers, and you'll see in just a second. I'll show you a picture of it. The majority of cells that are found there are going to be fibroblasts, and again, these are very strong. And I do want you to know, these are this is the tissue of tendons and ligaments. The tissue of tendons and ligaments. It has a very poor blood supply, and it heals very slow. Now, I don't want you to remember it as the dermis. Again, we'll kind of talk about that. It is going to, your dermis has multiple types of connective tissue in it. So anyway, but tendons and ligaments, dense, regular connective tissue. Right, this is our picture. I said it looks like a pink river of slime, basically. And you can see that all the fibers are really lined up this way. And what's happening is, over here would be a bone. Again, I probably should change color so it looks like that. Almost looks like a little heart. This will be a bone, and over here will be a muscle. And the muscle is going to pull. When it contracts, it's going to pull in one direction. And so these fibers just need to be strong in this direction. And so they line up in that direction. It allows the tissue to be strong, at the strongest it possibly can in that direction. It's giving up strength in either one of these. That's why, like, if you twist your knee or something happens with any force, it can snap, just simply because it's not strong in the other directions. And again, I hope all that makes sense. But dense, regular connective tissue, densely packed, regularly aligned fibers. That is the tissue of the tendons and ligaments. All right. This is the pictures that they have from the book of it. Again, I just wanted to make sure you see there's a big difference. And again, it's for someone to be a histologist, they're already a medical doctor and go to extra training for years to learn how to do this. So understand, I just want you in lab to identify my pictures. And on the lecture test, there's not going to be pictures. Now, we do not look at these two in lab. We talk about elastic connective tissue. We don't have a good tissue slide for it. And we don't really talk about dense irregular. But if we have dense regular connective tissue, that means densely packed, regularly aligned fibers. Hopefully you can just figure out that this means densely packed irregularly. So instead of having all the fibers line up in one direction, they all are lined up in different directions. And so instead of being as strong as possible in one direction and giving up strength in multiple other directions, if the fibers are aligned in this irregular fashion, it makes it strong in all directions. There's not going to be one single direction that it will be as strong as the dense regular, but because they're all over the place, they are stronger in every direction. And again, I hope that makes sense. Elastic connective tissue is going to have a lot of elastic fibers in it. And again, this is going to be areas where you can have a lot of stretch and relaxation, again, because the elastic stretches. Now, again, we don't have pictures of these two in our lab, and so not going to bring up anything with these. So those are the going over the connective tissues, connective tissue proper, and hopefully that makes sense. Take care and see you in the next video.